Good morning, everyone. I'm Jeremy Simon with 3D Universe, and I'm very pleased to welcome you to another session in our ongoing series, 3D Printing in the Workplace and STEM Education. This session is all about 3D printing materials, and it should be a great discussion. There's a lot to talk about when it comes to materials. Before we get started, I just want to call your attention to the URL that you see at the bottom of your screen, tinyurl.com/3du-webinar. That's the page where you can go to see all of the other upcoming sessions. We have several more coming up throughout the day today, as well as tomorrow. Some other great topics that you don't want to miss. So be sure to go to that page to get those all on your calendar and get the links that you need to join those other sessions. And that's also where we will be sharing the recordings and slides and other related information as a follow-up to these sessions. So with that, let me turn off the screen share here. And we'll go ahead and get started here. I'm very pleased to introduce one of our panelists, Matt Griffin, who is Director of Community Development for Ultimaker. I'm hoping that we will be joined by another panelist, Chris Jackson, who is the founder of Terrafilum Engineered Filaments. He seems to be having some difficulties connecting in, so hopefully he'll be with us shortly, but we will adjust as needed. In any case, as I said, there is a lot to talk about when it comes to 3D printing materials. And so before we get into the kind of the panel discussion and open Q&A, I wanted to have Matt give us a sort of an overview and get us started with some helpful information about materials to provide some context. So before I ask him to, thanks, Matt. Before I hand it over to you real quick, I just want to invite the audience to use the Q&A panel at any point in time to submit your questions as they come up. And as soon as we get through what Matt is going to share with us, we can then turn our attention to those questions and answer those along with some other discussion points that we have prepared. So you should have the Q&A button on the Zoom toolbar. Go ahead and put your questions in there at any time. With that, I'm going to hand it over to Matt. Thank you for joining us, Matt.
Great. Thanks for having me. Yeah, when Chris, Jeremy, and I were kind of going over things that we could cover here, we have all these lists of things that we could cover, and so we went from thinking, gosh, you know, how can we have this like nice optimized 10-minute version in the on Saturday to can we even get everything in within an hour? But what we're going to do is I'm going to, as Jeremy said, I'm going to give a couple, basically pull from my crib sheet of things that we talk about when we talk to customers from Ultimaker about how to think about materials. And we'll race through a lot of the main topics, but then we'll circle back and have a lot of room for deeper discussion when Chris joins and in the question and answer process, which will be most of the session. So, okay, so let's see here. Yeah, my 3-page outline is way too long for this. So, so generally, the big overview when talking about 3D printing materials, in particular in the field of FFF, fused filament fabrication, the extrusion-based stuff, you know, like this stuff that a lot of us are using and increasingly industry is using. There in the past, up to about 2009, 2010, there were very few materials. And it would come down to things like, you know, do you want it strong or do you want it in fast? Yellow, red, I mean, gray. There were almost no options. And that really spoke to how materials and the technology was used in industry at that time, which was, it was fulfilling the specific rapid prototyping role where you were taking you're basically prototyping the form, the shape. And that's it. Like you could maybe do a little bit functional, but that really wasn't, there really wasn't the room that there is now for really doing functional parts, end-use parts, the way it has become more popular in industry today. So there has been an explosion of materials coming to the space. And I would say it's not that there weren't materials existing in the world, and then when 3D printing came, magically we have these new materials. Most of these materials are coming from a very long history of exploring thermoplastics and other types of materials in industry. And but they're being accommodated for the various formats. And this happens for SLA, SLS, you know, all the other formats in addition to FFF. But with extrusion-based materials, there are some considerations. And so the quick overview is that A lot of these materials we work with are thermoplastics or have thermoplastic content if you have a composite material that has other types of fillers and additives. And that means that you can warm up and reform this and cool it back down and not have the same kind of full state change like you would with most typical materials, meaning that you melt it and it's forever changed to become this other type of material. That's a difference even in plastics between thermoplastics and thermoset material. Thermoset's like two-part epoxy, for example. You put them together, they become this new thing, done. You're never going to go back the other way. Whereas thermoplastics, you can heat up and reform it. And that's key because the first thing that's manufactured for the pieces that you're making is the filament. And Chris, who has joined us now, is going to speak a lot more about this, I'm sure. You need to make filament in a certain, very fixed diameter, put it on spools and be able to deliver it, because you're basically designing for a process. You're not designing for like a, there's not a craftsperson who's sitting there or a feedback loop on a machine that's saying, okay, we put in this amount of force and pressure and we're getting this amount. No, you're trying to plan at the head before you print. This is how the material is going to behave. This is what I'm going to get. And you stack up thousands and thousands of little retractions and moves and this kind of thing, and know that the material is going to basically go where you want it to go and have the performance that you want to have. So when we're talking to our customers about choosing materials, we always start with this, which is basically saying, how early in the process of your design can you start thinking about materials? And a lot of engineers in particular, when they're working on projects, they often want to not think about materials until they're ready to hit print, because they're really just fixing racing forward with CAD, getting that design set. And so what happens though, and this is the cautionary tale, I'll mention this at the end of my little segment here as well, is that you're making certain assumptions about what you can get out of the process if you do that. And it's not to say that's wrong, because there are some really great, kind of fixed processes. You can, I'm used to using, this nylon, and I'm going to get this kind of performance, and I'm at these kind of settings. And you can kind of, learn how the material behaves, have that incorporated into your process, and then kind of like set and forget to a degree. But you have a bigger range than just one material. It may shock some of you to know that you don't have to print everything in PLA. PLA has become a default for a very good reason. It's really easy to process. It's so easy to process, you can pause a print for a week and resume it, and it will weld down to itself, and you could just keep going. So that's, it also shrinks probably the least of all the materials that are available for the format. I'm sure there are exceptions, but for the most part, it shrinks the least. So the match to your digital design, to your printed part for form, is very close. So it's very easy, but it's an assumption you're making. So circling back, when we talk to people about how to use materials from among the Ultimaker customers, we start with how early in the process can you figure out what materials you can use? And part of that question is this: what is the goal for printing on this project? Because in a lot of cases, particularly the new roles for this desktop professional format in industry, you're not, you are rapid prototyping. You are figuring out form, and then you're going to produce it a different way. So the need for printing is different than one in which you are getting to use the full range of design for additive manufacturing, where you can do a lot of tricky stuff with how you incorporate the materials into the design so you can get more engineering properties. So, maybe you just need that form, in which case you need to streamline the printing of that to the most that you can. And that's why things like support materials like PVA and breakaway support material that peels off, it's a chemical resist, and there are some advanced scaffolding materials, everything from hips that you strip out with limonene that we don't like because limonene kills pets, so don't do it at home, to some high temp water soluble and lye strip out materials. So anyway, that circle back to that. So maybe you just need that form, in which case you are wanting to pick a material that has the least impact on you testing that form. But maybe on the other hand, you're looking to really leverage this system. And that's where you start to get to use the other questions that we ask next, which is maybe you can actually use a range of materials to make a functional piece. So then you ask the question, what is the context of use? Maybe there's a temperature requirement. Maybe there's you need to be in contact with skin or sweat, or there's chemicals, there's heat, there's a range of things. You can add that consideration, and the sooner you can add it, the better, because there are design implications for which material you might use. And so basically, you want to convert that information as early in your design as possible into a set of project parameters. And that's where it impacts things like, I'm designing for another manufacturing process, but I need to execute it along the way to learn iteratively in 3D printing. Or on the other hand, I'm going to target this format. I'm going to do things with desktop 3D printing. I'm going to do things with maybe SLA or a different format. And I need to know everything I can squeeze out of the materials. So you turn those into material requirements, and then you can design to that, and you can prepare for that early in the process. So I will wrap up my point with just two elements here. One is if you are able to really modify your design to accommodate materials and take full advantage of materials, then you actually get to split once again into two considerations. One is architecting materials. Now, you see some of these opportunities with things like Autodesk generative design or end topology or various lightweighting and other solutions, where you can really think in terms of how the performance of the materials and the loads and requirements, and you can use it to get more engineering properties out of a material you might use. Then it's not just like, what is stronger, nylon or tough PLA or polycarbonate. You actually start to think about, okay, if I have thin features, how can I get, I want a little part of this device to be, this printed part to be flexible, and part of it to be super stiff, really reinforced. And so you can do that in the design. And you should think in terms of how that material performs, but also bring that into guiding your design. And the other half of it is the material choice half. Maybe you need to actually split up that design into multiple materials and have a flexible material and an armature material, and to really execute, the engineering needs that you have there. And so the last note I'll make is, so that carries us all the way through to, maybe tuning the design and maybe picking the right material and having output. There's another layer. Once you add post-processing, you open up the full machine shop. You could do all kinds of things. Now, a lot of people won't want to do this, and it's interesting to see people think about this in terms of delivering a part from, like, if you think of a service bureau model, you have a service bureau create a part for you. Then you send the files, and you want something back really pretty, really impressive, because it's persuading you that it's a good part, right? If you're designing for yourself, you're designing for use. Like, say you're shoring up a manufacturing process, you're making jigs or fixtures. They don't need to be pretty. They need to function right. And so you don't care about some of that. So you don't have all those layers. So from that perspective, it's actually advantageous from a business perspective to highlight, what is the route to get the output closest tied to your digital design. And you don't want a lot of post-processing unless you're executing something specific. On the other hand, if you're walking in with a visual prototype and you need to persuade somebody your design is good, they're going to handle it, and they're going to make a decision about your product, you might spend more than 50% of the process of making that on post-production, making it really, suited with the right coatings, the right painting, sanding where needed, so that when you hand that off, it gives that person receiving it the full sense of the product. And so post-processing is not an afterthought. It is almost the entire deal. And you are speeding up the process to execute that to the best you can with materials. So, okay, that's my launch spiel. This is how we talk to customers about materials.
That's awesome. Thanks so much, Matt. And I think that gives us a great context for the discussion, because it really gets us to how we lead up to our decision of what materials to use. And I think kind of sets the stage for some of the other things I'm hoping we can discuss here. to get into some of the specifics of those materials. So I'm very pleased to be able to introduce now Chris Jackson, who's joined us from Terrafilum Engineered Filaments. Thanks for joining, Chris.
Sure, thanks for having me. Can you hear me okay?
Yeah, audio's coming through loud and clear.
Awesome. So this was a first experience for me to use the iPad versus my laptop. So, all right, but that's cool. The iPad's working.
It's always exciting. There's always something with these webinars, but I'm glad we're all here. And
looks great.
I want to re-invite our attendees to please use the Q&A panel. I want to be sure that we get to your questions. This is really about what you are looking to learn here today. So please do go ahead and type in any questions at any time into the Q&A panel. Until we start getting some of those questions from the audience, I have a couple of points that I'd like to touch on with our panelists here. So I'd actually like to start with you, Chris, and this is kind of following on a little bit about what Matt talked about. You know, there are a lot of materials on the market. The selection has just exploded, as you both know, and not all materials are created equal. You know, there's a lot of materials that are lower quality than others, and some that are much higher quality. Right. As somebody who has a reputation for developing very high quality materials, Chris, I'd like to hear your sense of kind of what those different factors are that go into making a high quality material versus something that might be lower quality and not give you the same performance.
Okay. Well, thanks for having me, Jeremy. And I want to build my points off of what Matt was saying, because I thought Matt's points around materials were spot on, especially when you're selecting materials and how to do it, because many of our customers are manufacturing oriented that don't care about what it's going to look like, you know, in terms of how pretty it's going to look. They care about functionality. So there is a huge important distinction, and that goes into material selection, right? Because not all filaments are created equal, and a couple of things that can happen with cheaper material is it depends on how people are producing it. But for example, there are fillers that you can put into any one of the materials that make it cheaper. You can still get the diameters you require, but it's not all what you're expecting it to be. So for example, a PLA filament that you might buy that is foreign produced or something that has a cheaper price point, it might have a filler in it that makes it more brittle. So you're not necessarily getting a PLA that is, say, 98% PLA or more and has the properties that you're really looking for. So it's an important distinction to be able to say all materials aren't created equal. And at least in my experience, and you know, I'm not going to talk for you guys, but in my experience, you kind of get what you pay for a little bit. And
I'd agree.
Well, I was wondering if you might talk about like regrind and things like this. I mean, because in particular, you have expertise in sourcing and finding exactly the right like base polymers to bring in. And I don't think that many customers really understand how filaments are made.
Sure. So how about if I did, those are two very good questions, Matt. They're distinctively different. So let me attack the recycle stuff first, and then I'll kind of walk through the process. We pride ourselves in being able to take and utilize both bioengineered materials as well as making things out of different kinds of either, I'll call it generically recycle. And what I mean by that, in my earlier presentation, I talked about rescuing. We like to rescue virgin material that's been out there, because there's a lot of molders out there that use materials similar to what we're going to do, and they're compounds that are absolutely stellar, but they're not going to use it because they've only got a small amount. So that's one of the types of recycle. It's already been done for us. It's already pelletized, so we can use it in our process. The second is repurposing material. And what I mean by repurposed material is it might be slightly off spec. This depends on what you're talking about off spec. If the off spec is because it has a slightly different molecular weight, when resin producers produce materials, they're looking at a lot of different factors, some of which are molecular weight. Well, if the molecular weight that they have for that particular polymer is outside of the spec that they're using for that compound, it still could be good filament material because it's not necessarily impacting to a great degree the material that we're going to produce as a filament. It's still, for example, polypropylene. It's still the same material, but it exists at a wider range of molecular weight, which in turn means it might have a slightly different bulk density. Now, to you folks out printing, that slightly different bulk density might be you're putting 1.1, for example, or 1.05 in your printers for the density requirement. Well, this might have 1 decimal point more than that. And so your prints aren't going to change appreciably, and your quantities aren't going to change appreciably. So it's not necessarily that bad for you. And we know what those are, and so we make sure that we keep those within tolerance. And the third thing is recycle, regrind, just what Matt mentioned. So we will take materials from our process, or people that have sent us back spools that might have filament on it, or parts that they don't want to use. We will regrind that material. We segregate it into different types of polymers, different colors, and then we use it back into our formulations. And you can only use that back into the polymer at a certain percentage. And from my polymer background, I kind of know what those percentages are, but basically what it ends up being is you don't want to impose too much heat history on the polymer so that it doesn't perform when you go to actually print it. And so those are the 3 kinds of things that we like to use for the materials that are out there. Now, obviously there's a 4th, and that is biopolymers. So we will buy biopolymer virgin resin because it's a biopolymer. There's 2 other areas that we're looking at extending. And one of them is a partnership that we put together with XG Sciences, where we are using a graphenated material as part of our polymers that we're looking for. And graphene is a nanoparticle of carbon. And it has, at least in my opinion, superior properties to carbon fiber in that it's less abrasive than carbon fiber materials that you would print with. And that nanoparticle allows it to have some unique properties in terms of lubricity. So what that means is it's actually going to print at probably a little higher rate and actually perform better with your layering, because it's going to retain its heat during layering a little bit. And so all of those things from a graphinated perspective are great, but it has even another benefit called physical properties. Physical properties are just like carbon fiber are dramatically increased. And in some of our samples, we've seen physical properties improve 30 to 50%, depending on what we've actually printed with. So 2 things that I like to think about for materials that are going to print well. You got to come up with what are going to be the right impact strengths that people want to see. And those are dictated by the chart that Matt accurately described in terms of the dots and what are good impact resistance and what you want to see. But the other is, I like to think about it in terms of back in the plastic rheology segment of melt flow, because the higher the melt flow actually gives us performance in some of our recycled, refurbished plastics, and that's what helps us be successful. So we look at a very tight tolerance performance for melt flow when we're making our products, and I think that's a really good key. I apologize for going a little longer here, but those are kind of the basics. When you get into the production of the filament, blending is important. We blend the materials ahead of time, way ahead of time. Drying is important. We have to make sure that the dryer, the moisture content of the different materials are within tolerance. Some materials shed water really well, and you just have to get kind of the base water off, and other materials actually absorb water in the molecules, and you have to make sure you dry that to a certain percentage. The reason that's important is because that will cause printing issues later if the material is wet. Wet materials, and you would never detect it, but wet materials over the spec could cause bulging in the print. It could cause mislayering. There could be all kinds of things that you in finish quality that you don't want to see. And those are kind of back to the materials, you get what you pay for. A lot of people don't take the time to actually do that processing step and then measure the performance. Am I drying to the point where it needs to be? And then you basically compound it like any other compounder would do through an extruder. But the thing is, what the secret sauce here is temperature profiles as well as screw design. They both have to be matched specifically so that the different types of material you're processing are going to create that standard filament that you're used to seeing in very tight tolerances of 1.75 millimeter or 2.85 millimeter diameter. And then those properties can even get further adjusted later downstream as you're pushing that through the system, depending on the performance of the polymer, how rigid it is. It could actually stretch after it goes through sort of the storage unit and combination to get it on your spool. So it's a very tightly kind of woven, I guess, process from the front of the material selection all the way down through processing conditions, machine design, and then onto the actual spool before you get it. So there are some people out there that can make materials, but they don't have some of those elements. They make the material, it's not necessarily as good as others.
Yeah, yeah, absolutely. Thank you for that great overview, Chris. And we actually have some questions coming in, and there's a couple here that relate back to what you were talking about with your partnership with XG Sciences and the graphene enhanced filaments that you're developing. So maybe it would be appropriate to touch on those first here. First question on that topic is do you have any sense of when those graphene enhanced filaments might be available?
Yes. We were hoping to be already in market, but given the COVID situation we're all in, it's kind of delayed us. At this point, we will be getting back to the development plan that we have in place in May. The first samples that we will have available to people will be in June, and we're going in a progression. The first samples will be an ABS graphene composite. We will go to some of our composite materials that we already produce, the PLA TPU, the ABS PLA, and the tough PLA, and we'll get those into some graphinated forms that you can actually be able to articulate how different are they versus what the base products are. Beyond that, then we have others that we're going to go into, which is an ABS polycarbonate composite that a lot of people print with today. That graphene is going to add some actual printability to that composite that doesn't exist in the marketplace. And we have some future selections that we're really excited about, where because of our eco-friendly nature, we're going to be working with a company, and I can't announce any kind of partnership related, but what we're going to do is we're going to be able to offer many of these same materials in biodegradable forms. So we're really looking forward to some of that stuff, because that particularly goes right to our nature of why we exist.
Yeah, I can't wait to get my hands on some of that stuff, Chris.
I have a quick question about some of these materials. Will they be enough conductive that you can use this for routes to coatings and things like that, or not necessarily? It's more about processability.
Can you explain that, Matt? Just a hair.
Well, some uses of graphene nanoparticles allow you to have high resistance conductive material, so that you can then you can use it for like electroplating, things like this as well. Is that at all in the consideration for you guys?
I understand your question. Yeah. So great point. We actually are in our development plan having different materials that are going to have different properties. To your point, you can use graphene to make conductive materials. You can also use graphene to make ESD safe materials, believe it or not. So those are the things, and they're kind of two widely different spectrums of uses, right? But it's got some very unique things that we can do with it. And XG Sciences, for those of that you don't know, are affiliated with Michigan State University. And so there's a lot of research behind, sort of the graphinated materials and what we're doing.
That's really great.
Yeah, so there's a couple of other components to this question. The next part is, what are the physical and mechanical properties? And you already talked about some of that with what the actual nanoparticles add in terms of less abrasiveness and lubricity, et cetera. What about other physical properties? What does it do when you add in graphene to a material? Does it increase stiffness? Does it change the strength measurements? What other kind of physical changes does it introduce?
Yeah, there are two. so you guys will may or may not know it. I mean, I loved Matt's chart that he had at our original session because it's got a lot of really cool, just subjective things about different materials and how it's utilized. But we think in terms of like tensile strength and flexural strength, and both of those are dramatically increased. In particular, we've seen, like 30 to 50% increase in those kind of strength properties. And it's because the nanoparticles actually help, just like carbon fiber does, but it helps provide that stiffness on a molecular level that the regular polymer doesn't do. I won't bore you with the chemistry, but it actually helps the bonding agents.
Well, that's a great lead in actually to the next part of the question, which has to do with that bonding. This individual is asking if it's going to be possible to print this graphene enhanced material in combination with other materials, like maybe printing a part that's half in a flexible material and half in a graphene enhanced ABS or something like that. What kind of combinations does that allow for, or does it change those options in any way?
Well, Matt shared this chart, which is really good, and it talks about the difficulty in printing and that kind of stuff. So a sneak peek, I'll give you. Our ABS, for example, has some printing properties that people that are familiar with printing ABS know that it's you're subject to some warping and shrinkage when you're printing. On the same vein, we've done the same with polypropylene, and that's even worse. Due to the characteristics of the material with being graphene and it actually providing at a molecular level some heat performance that you don't get with the base materials, you actually see less of that difficulty in printing. And that's just one that kind of stuck out with me. And of course then, given that kind of situation, or even with today's materials, assuming you're going to do two different heads or even stop and pause the printing, it absolutely is possible to take a graphenated material because you want strength on the outside or whatever, and maybe you want something softer on the inside. And you can actually have those two materials be very compatible. I think that we haven't, that is my supposition at this point, because other than the first part of it, which we've already tested, the second material point, you're already mixing materials if you're going to do a PLA and an ABS combination, or breakaway material and another material. So to that perspective, you're still going to do it. The real question is, how much bonding might you get between layers if you're going to use two different materials and you're going to do that bonding between the layers? That we haven't tested yet.
Okay, great. And then the last component of this.
By the way, that is just amazing. I talk to a lot of materials companies, and they're not always able to share all this level of detail. So I just want to emphasize for those attending here that you call up a typical material company, they're not necessarily going to share their process or how they think through these things. This is really very helpful, and increasingly the way things are going, because people are now relying on more performance outcomes from these materials. And so so Chris, thank you for sharing about this. And I have
agree.
one tiny question.
Sorry, what was that, man?
I have a tiny question about your response about the graphene related stuff. Is it that it is basically routing heat through the material better? Is that one component of that? I'm completely fascinated. Nobody has shared results about this.
So graphene has a unique property in that it holds its heat property very well. So when you're processing it, in general, it retains its heat. That allows it then to be able to, when you print it, it actually allows it to adhere better to each layer without it shrinking up around itself and that kind of stuff for some of these other materials. That opens up a wide range of materials that you can't usually do today. So that's why we're so excited about it.
And I just want to follow on to what Matt was just saying about the level of knowledge that we're seeing here with Chris. It kind of goes back to our earlier point about not all materials being created equal. One of the things that we've seen with 3D Universe with the materials that we offer, and we're very selective about what we offer. We do a lot of testing before we put something on our product offerings. But what we see is that when customers try out a certain material and they like it, they keep coming back, and they tend to keep going back to those same materials they've had a good experience with. And I think part of the reason for that is because that there is a big mix out there, and some people have had bad experiences with other materials. So when they find something that prints well and reliably, they're going to tend to go back to that material. And so I think that goes back to the kinds of companies that are producing materials, because there are companies on the market that might have a lot of experience in plastics, but they might not have a lot of experience with 3D printing plastics, because there are some very unique concerns when it comes to putting plastics into filament form, and Chris touched on some of that. And
There's
so
a
I think,
subset of that too, where you have companies that have started with making 3D printing plastics, but they actually do not have polymer science experience.
that's right.
And so you get the opposite. So people who have this deep experience with injection molding can sometimes bring some knowledge back from things that were addressed in the 80s and 90s that will help additive materials. And it's only in the last 5 years, I'd say, that some of the people running into the additive materials space are bringing that knowledge. So you have both sides of that. I just wanted to comment that because that's something that we know that our customers don't know. They assume that the people who have offered materials in the past are drawing on all the things you can do with polymers. And we're finding that one of the reasons polymers are so exciting right now is that there's just a lot more thinking coming into how you can get the properties out, both from folks drawing on deep chemical knowledges, go all the way back to building the chemicals up, carbon by carbon, to the other side of, experience with additives and relaxers and all these kind of things to really suit things for use. Anyway, I just want to interject that because it's not something that, again, we feel that our customers know as much as we would like them to know.
And then there's also a question about the price point for this graphene enhanced filament. Chris, I know you haven't gotten to the point of finalizing all the pricing and everything, but do you have any sense of kind of the general impact of pricing of bringing graphene into the equation? Like how significant of a change in price might that have?
Well, I think it's going to be, I don't know, I'm not going to give a price point because I don't have one, but I think in general it's going to be a little more expensive than carbon fiber. And then when you're looking at composites and that kind of stuff, it could get a little bit more expensive than that. But I mean, in general, it's what we're going to try to do is provide a competitive product out in the marketplace that is at least allows people to use it and not try to be sort of this aircraft niche, kind of like composite material that, unless you're in the aircraft industry and you're working on aircraft engines, that you're going to want to be able to pay, $400 or $500 a roll for. So, I mean, we're going to try to make it more available to a broader range of, sort of where we think it's at is industrial type customers. Of course, there could be education customers, specifically universities and those kind of people that are looking at potential different applications and what they might want to use it for. But I think, for the base education STEM people, it might not be something they really need for that perspective, because it is more of a performance material.
Right, right. Okay, well, we have a couple more questions in Q&A, but before I get to those, I actually wanted to jump in here with something that's been kind of on my mind, and I'd love to get Matt's input on this. One of the things that I've seen through 3D Universe is I'm sometimes surprised by how many people seem to stick with PLA. There are so many wonderful materials on the market, and I sometimes feel like they're missing out, on these great materials that have all these awesome properties. I think there's a little bit of a perception of some of these advanced materials being a lot more difficult to print and very hard to get them to have good bed adhesion and stuff like that. And I think maybe that was more the case in the past with older 3D printers and some of the older materials.
Yes.
What have you seen now? What do you see these days, Matt, with the advancements in the 3D printers and the materials in that regard? And how would you encourage people to maybe explore some of these more advanced materials?
Absolutely. That is a key question. So, it's funny if you look at the very beginning of desktop 3D printing, or you look at kind of a little bit of a kind of stalled out mode of industrial 3D printing in the late 90s. You had so few options, and it was really about engineers and designers wanting to say, okay, I just want the thing that works the way that and they're missing the assumption part, which is works the way I'm familiar with them working. It's you know, I want to choose that, and then I don't want to think about it again. Then I want to just just go to that material and it works. And the reason is so before it was PLA, it was ABS. And ABS is unless you accommodate it. So what Chris was talking about is a big deal. ABS is the most annoying thing to print with. If you use pure ABS, you don't have a great environment to work with it. It is so frustrating. But that was the default for a long time, and you would even jump through hoops in industrial machines and use PLA as the as a support material and strip it out with with lye in order to be able to get that ABS. Why were people using ABS? Not because they really understood what ABS was useful for. It's because it was a very common manufacturing material. They were, engineers were used to it from their engineering programs. It had this, this huge role in automotive up to a certain point. And even though the field moved, people didn't get trained on the new materials. And so you'd say, okay, it's time to print, therefore ABS. And then now with the prevalence of FFF and all these desktop units, PLA the same way, but for a different reason. PLA is the easiest to process. Well, I mean, within a lot of caveats and which PLA and all this kind of stuff, but it's you don't necessarily have to fuss as much with understanding the mass, the heat distribution of heat through the part. You don't have to tune your design as much to get what you want. That's why it's very popular for like printing patterns and things like this, because it's going to pretty much go where you put it, and you can focus on some of your processing parameters to get there. And so people think, oh, well, I had a great experience with PLA. I just clicked the button and I used the profile and it works. So that's what works. So this machine does PLA, and it's too bad. I mean, that's totally makes sense. And the reason it was so frustrating is exactly what you brought up, Jeremy, is that you switch to another material. You have this one that's suited to your need, but you don't really necessarily understand the processing parameters. So you hit print and you go with it. It's like, oh, it does not work out. You have this horrible experience. You're like, oh, well, this machine doesn't do that material, because I'm used to it doing this other thing and having no fuss. So this is a little bit of a long lead up to something that Ultimaker has devoted a lot of our materials approach on. We have the Material Alliance. You might have noticed we are working directly with a lot of the top providers of chemicals and filaments in the world, and adding more as we go. And one of the main reasons we're doing this is we're trying to speed up that process of getting good profiles in the hands of those who need to use them, so that they don't have to do what you really have to do. If in other formats, if you're adding a new material in your manufacturing process, you can expect to spend at least a week, maybe a month, just figuring out the parameters, just figuring out the processability, and figuring out how you can use it and accommodate it in your design. Well, with 3D printing and it being primarily a digital format, I mean, we don't think about it, but you're really driving it from your digital design. You're not used to. You want to solve it with software. You want to solve it with. You don't necessarily think that you're going to have this real world, material development stage. You want to hit print and have it do what you want it to do. So we took this and we realized that up until really the middle of this, 2014, 2015, a lot of the processing parameters that anybody in additive would see is either what they've developed in-house at cost and effort, or what's developed by the OEMs of the hardware. And we thought we did a pretty good job in setting some expectations for what we were going to try to accomplish with our base profiles, and they are very pretty. But in the design for 3D printing talk that I gave on Saturday, the little one, I brought up at one point a little chart that shows the key parameters and what trade-offs we made to make a profile that works pretty well for a lot of our base profiles, and our standard format, it bends towards pretty. It bends a little bit more towards a pleasing part, which might not be your need. Well, we put the process of developing profiles into the hands of the developers of the materials. And we create a whole program where we can get hardware and some software tools and some parts into the hands of those polymer companies so that they can experiment knowing their full knowledge of what's in there and how they have accommodated the end results they want with the material they're putting on the market. And so there are an incredible number of counterintuitive factors in there. Everything from how you even think about things like retraction and pressure that allows this route to produce a profile that is much closer than most of our customers are used to when it comes to adding a new material. And the end result is that when you go to use an advanced material, you want to bring in a composite material you never used before, you're standing on the shoulder of some people who have really been looking at this problem, and they've at least accommodated it to get to the hardware. They still haven't accommodated it to your design, because at the end of the day, this format, as opposed to some of the other, additive formats, is always geometry specific. You are never going to have like this profile rules all profiles. No, you're never going to completely solve the optimized set of parameters for your part until you accommodate to that part. But you can certainly start in a better place. So this is really changing things, because people who are used to saying, oh, I grabbed this new material I saw online, it looked cool, has these cool properties, but when I processed it, it broke my machine, or I had, I just couldn't get even adhesion on the plate. This takes a lot of that mystery out and comes with a lot of like technical data and processing advice. So you go to Cura, you go to the marketplace, and you click and download one of these profiles, and you can also see the MSDS and the technical data sheet right there. You could read about it and see advice for temperatures and things like this. So it takes a lot of that mystery. You're still going to possibly, if you're really finishing with 3D printing, you're going to still need to explore further the parameters, but you can do what you really should do, which is change one parameter at a time, working through to an optimized set. And so you start in a better place, and that drastically reduces time. So yeah, anyway, that's a long answer, but that is what's missing when you want to add these other materials, and why people just say, well, the default of this machine is PLA, so I'm just going to use PLA because it always works. It's because those are pretty battle-worn parameters, and your expectations are all based on them.
Right, right. And that's definitely been my experience. I mean, that materials marketplace has been a tremendous help. You have a huge array of different materials to explore in there. You find one that suits your needs, one click down with the profile, and you're ready to go. I mean, it really is a huge advantage. And the other thing that I've found to be helpful when it comes, some of these materials are a little bit more challenging, even with the right settings. And a lot of that challenge comes down to bed adhesion often. Some of these materials just don't stick as well as others. And so one of the other things that I've personally found that has made 3D printing just much more enjoyable overall is having the right adhesives. We offer the Magigoo line of 3D printing adhesives, and I personally just love those. They have a number of different formulations for different types of materials. And if you use that right formulation, the right kind of Magigoo, you put a little bit of that on your glass build plate. What I love about it is your prints stick really well. It helps to avoid any kind of warping or anything like that. But just as good is that at the end of the print, when the bed cools down, the adhesive releases. It just totally lets go, and your part just, you can just lift the part off. You don't have to fight to, get it off the bed and pry at it with spatulas and things like that. So I think that's another component of just makes it a much nicer experience in working with some of these more advanced materials.
I'd like to expand just a hair off of what you said, Matt and Jeremy, because one of the things that I see that's growing, and you haven't had a source in a long time or anywhere specifically for filament to be able to ask consultative questions about what materials I should use, how should I do it, and I think you're seeing more of that with printer manufacturers. Ultimaker is a great example of some of that stuff, and it's so appreciative. Clients come to me a lot and say, well, what should we use? Ben from Caterpillar presented something, he didn't touch on it a lot, but it was one of his sort of urethane injection, or not really injection, but it's a urethane structure where they needed a housing that they're injecting urethane in to get sort of a mold out of it, and that's what they were trying to print. And they were using Ultam and some real expensive stuff, and they were spending thousands of dollars. And they came to me and I said, well, why are you using that? There are other materials you can use, A, that print faster, and B, you don't have to have something special to print it with, and C, you don't need that kind of strength. There's some materials out there that can give you that kind of strength. So, but I think in general, the way the industry had gone, like you were talking about, Matt, is there was really none of that consultation out there, none whatsoever. So I find it refreshing that, Jeremy, you talked about being selective, but I find it refreshing that there are avenues out there that you can get that information today. And, I think the three of us are prime examples of that. We certainly don't have any problems answering questions like that. And it only makes the printing experiences easier. I want people to use the technology because it is so successful, and you can do a variety of things with it.
Absolutely. So there's a related question here from our audience. Someone is asking, how does the material selection process differ based on printing process? So for example, using FFF or FDM versus SLA. And they're asking, is the material selection only a concern with FFF? So I don't know, Matt, do you want to touch on that?
Yeah, I was just typing a response right now because I wanted to make sure we get to this. So two things there. First, if you have both options, if you are trying to decide, you have a part and you want to decide if it's SLA or FFF, which is actually, honestly, very often the situation. I'd say we have a lot of customers who have access to both. Then there are a couple of places you can start. And these are guidelines. But the overarching thing is this. There is a lot of work and advances happening in materials for FFF and materials, for SLA and DLP. In general, if SLA and DLP can achieve higher resolution and transparent materials results much easier than you can with FFF. But there's a trade-off in that FFF accommodates a lot more of the rigorous and tough materials that can handle a lot of abrasion, a lot of use. So it often comes down to rules of thumb like this, and this is not perfect because, once again, there's a lot of thinking and exploration going into changing these materials now. If you want something outside, you want something functional that can handle a lot of wear and tear, you're probably not going to look at SLA DLP. If you need something that is incredibly small and very, very detailed with no layer lines, you might do SLA or DLP and do things like some of those patterns for fine jewelry. Spend a week printing it, but you cannot achieve that necessarily in the same way with FFF. But within the family of materials for FFF and for SLA DLP, you have a lot of interesting work in expanding the performance set. So in SLA now, you now see draft materials that can print really fast and rigid materials that are stronger. And there are machines that will produce really strong pieces that you can use, particularly for like a pattern or a process stage to produce a final piece. And that work is pretty advanced. In the FFF world, you heard from Chris a unique chance to really hear how people are working through and accommodating engineering properties by the components and additives that will help boost those performances. So you see a huge range, particularly now with all the composite materials, where you might essentially be using the thermoplastic for delivering, as the printing matrix to really make sure you can get what you want where you want it. But then an additive can bring another engineering property in. So yeah, so you get a chance to draw on both things. And I would say there are a lot of resources out there you can go look at for SLA and FFF that look at the full material range within both. There aren't many that put them in the same list because we all end up, being a little competitive with each other. But it's a really good time, and so you can reach out to people who say sell both. and get a lot of good suggestions. And you can just, you can bring your engineering properties to folks working with either material and say, I'm really targeting this kind of stiffness. What do you have? Yeah.
Excellent. Thank you, Matt. So we're coming into the final few minutes of our session here, and I thought it might be appropriate to, as we kind of close up here, to talk about something that's related to all this. You know, there's so many great materials, and I hope that our audience will take the opportunity to experiment and try out some of these great materials that are available. And through doing that, you're going to end up with a lot of empty spools, right? You're going to have all these
Right.
spools around wondering, what do I do with all these spools? We don't want them to just end up in a landfill. Chris, can you tell us a little bit about the spool recycling program that you offer and what our attendees can do, where they can send those, maybe even, you know, put something into the chat if you have an address that you'd like to share that can allow them to recycle those spools?
Sure. Well, honestly, we love to recycle spools because I know how bad it is if you have an office full of spools and you don't know what to do with. And you're not, all of us are pretty much environmentally conscious. We know if we dump them into the dumpster, you know exactly where they're going to go. We don't care. We want them back. We want your spools. If you have empty spools, we want to take them back. We find it a good way to reuse and refill those spools. We clean them up. If they're usable, we'll reuse them. You know, a lot of manufacturers may not want to do that, but for us, it's environmentally the right thing to do. If you have parts and you have little pieces, tell us what it is. So we segregate it in our bin. We'll use it in our regrind. I will have Jeremy add our address and stuff. Jeremy, if you don't mind doing that, shipping address back to us. Please send them. It's okay. And you know, like I'd like it to be ours and Ultimaker's material and that kind of stuff and Jeremy's, but you know, look, if you have Polymaker stuff, I want the spools because it's the right thing to do for the environment. I don't want you to throw them away.
That's so great. I have so many spools from COVID-19 printing. I'm going to send to you. I mean, I think I just told the rest of the kind of network here in New York City, we're all working together. I mean, I think we're going to send you a lot.
That's great. I just put the address there in the chat, so I hope that our audience here will take advantage of that. And as one of our attendees just said, boy, that was a quick hour, and we could easily spend, you know, several more hours talking about materials. There is just so much to talk about. I do hope that this was useful, though. I want to give a big thanks to both Matt and Chris. Just a tremendous amount of knowledge and experience that you both brought to the table here, and I really appreciate your time today.
Yeah, you're welcome. I loved it.
Yeah,
thanks for including us, and thanks for giving access to Chris telling these real insights. I've been so hungry for more filament companies to really talk about some of the stuff you talked about. So appreciate it.
I hear you. It's really been wonderful to work with Chris. I've learned so much from him. So it was a great partner to have. So thanks everyone for watching. It's been a lot of fun, and we will be sharing a recording of this as soon as we're able to get it up on that page that I showed you earlier, tinyurl.com/3du-webinar. So you'll find it there. Thanks everyone for joining. Have a great day.
Thanks everybody. Have a great day.
Thanks so much. See you all.